Hi everyone, it's Linnea Tucker. Wanted to give you a little extra help with graphing your nonlinear functions. This time, instead of giving you hints and tips and whatnot on finding your vertex and where you go from there, let's just keep the big idea the big idea. We're given a function. I'll give you 3 functions. Let's just create a table of x, y ordered pairs that you can graph, okay? That's your big idea. We're just going to graph using ordered pairs. Here's what I want you to do. Okay, what we're going to do is we're going to choose x values, and then we're going to calculate the corresponding y value and graph each one of these points. Now, typically the grids that we give you on homework or on tests go from a value of positive 10 in the x direction to negative 10 in the other x direction. Let's use those values for our x. And I want you to use all of them until you hit a spot where you can't go any farther. Okay? So we're going to start with 0. And then going backwards, -1, -2, -3, -4, and so on. Well, I've only got +8 to -8, but I really want you to go -10 to +10. Somewhere in here, you're going to have to stop because you're probably going to run off your graph in the y direction. Now, what we're going to do is I like to start with 0. So I'm going to plug 0 in for x right here. So it's going to be 0 minus 3, square that, then take that answer and add 2. Well, 0 minus 3, here we use our orders of operation, do what's inside the parentheses first. 0 minus 3 is -3. Now it says square it. That means take -3 times -3, that's +9. +9 plus 2 is 11. That's a little bit off the grid, but we can fudge it. So let's go over here. 0, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right there. Okay? Let's keep going. 1 minus 3 squared plus 2. 1 minus 3 is -2. -2 times -2 is +4. +4 plus 2 is 6. If anybody makes mistakes, it's squaring a negative number. When you take a negative number and multiply it by itself, it's always positive. So now we have the ordered pair 1, 6. So 1, 1, 2, 3, 4, 5, 6. Okay? Let's go here. 2. 2 subtract 3. Square it plus 2. 2 subtract 3 is -1. -1 squared means -1 times -1. That's +1. +1 plus 2 is 3. So I've got the ordered pair 2, 3. 2, 1, 2, 3. Let's put in 3. So we're going to have 3 minus 3 squared plus 2. 3 minus 3 is 0. 0 squared is 0 times 0, which is 0. 0 plus 2 is 2. So we've got the ordered pair 3, 2. 1, 2, 3, 1, 2. Okay? Keep going. 4 subtract 3 squared plus 2. 4 subtract 3 is 1. 1 times 1 is 1, plus 2 is 3. 4, 3. 4, 3 is right there. If we put in a 5, 5 subtract 3 is 2. 2 squared is 4. 4 plus 2 is 6. So we've got the ordered pair 5, 6. 5, 3, 4, 5, 6. Let's put in a 6. 6 subtract 3 is 3. 3 squared is 9. 9 plus 2 is 11. So I've got the ordered pair 6, 11, which is right here. Now if I put in 7, 7 minus 3 is 4. 4 squared is 4 times 4, which is 16. 16 plus 2 more is 18. That's way off our grid. So we can stop here. Now if you go backwards, here we've got negative 1 minus 3. Negative 1 minus 3 is negative 4. When you square it, that's negative 4 times negative 4, which is positive 16, plus 2 gives you positive 18. And that's way off the grid. So you can stop. We're done. And we actually see, okay, that's not a very good curve. Let me try again. You can see our quadratic function, which looks like a U. I hope you can draw it better than I did because that looks pretty bad, but I think you guys get the idea. One thing I want you to know about your quadratics is that we have an axis of symmetry that runs right through the vertex. Here our vertex is at 3, 2, and we have a vertical line that runs through it. The thing about this is all of your points reflect off that line of symmetry. If you've got a point that's 1, well, that color's not good. Let me use pink. This point is 1 to the right of the axis of symmetry. You've got another point that's 1 unit to the left of the axis of symmetry. This point is 2 to the right. Here's 2 to the left. Here's 3 to the right. Here's 3 to the left. And you guys can see that symmetry. If this is my vertex right here, you can see the symmetry here in the table. Okay? If you plot a point that's way out here and the others are doing something like this, trust your instincts. That's way out of whack. Go back and double check. Okay? There shouldn't be a point way out there. One last thing I want to say about this before we go on to the next function, and I probably should have said it at the very beginning. I know that this function is quadratic because anywhere you see a quantity being raised to the second power, or maybe you just have x raised to the second power, raising it to the second power makes it a quadratic, and all quadratics take on this ever-widening U shape. Okay? It may open upward or it may open downward, but it gives you that symmetrical U shape. Okay, so let's take a look at an absolute value function. Absolute value functions all have absolute value bars right here, and they all graph as a V shape. And you'll see that when we get done with this. Okay? So once again, the graphs that we give you, the coordinate grids we give you, go from positive 10 to negative 10 in the x direction. Go ahead and set yourself up a big table and do the same thing. Go from positive 10 back to negative 10. And I always like to start with 0 because 0 is just an easy number to work with. So my first point I'm going to plot is the absolute value. I'm going to replace the x with 0. 0 plus 2. Well, 0 plus 2 is 2. And the absolute value of 2 is 2. So now I've got 2 minus 1, which is 1. So let's plot 0, 1. There's my first point. And let's go in the positive direction. I'm going to substitute a 1 for x. So I have 1 plus 2. 1 plus 2 is 3. The absolute value of 3 is 3. 3 minus 1 is 2. So I've got the ordered pair 1, 2. 1, 2. Let's use an x value of 2. Absolute value of 2 plus 2. Well, 2 plus 2 is 4, and the absolute value of 4 is 4. 4 minus 1 equals 3, which is right here. let's use 3. Absolute value of 3 plus 2, well 3 plus 2 is 5. Absolute value of 5 is 5. 5 minus 1 is 4. And I kind of already see a pattern here, don't you? Yeah, I think as these continue, as each one of these x values increases by 1, it looks like my y values are increasing by 1. So I'm thinking, I mean, I can go all the way down to 10. Well, I can go all the way down to 8 because, well, no, I could probably go to 10. 8 plus 2 is 10. Absolute value of 10 is 10. And 10 subtract 1 is 9. I mean, it still fits on our graph. But I think I'm going to start working backwards. I'm going to put in a negative 1. So I'm going to use the absolute value of negative 1 plus 2. Negative 1 plus 2 is positive 1. The absolute value of positive 1 is 1. And 1 subtract 1 is 0. So I've got negative 1, 0. Negative 1, 0, right there. Let's put in negative 2. So I've got the absolute value of negative 2 plus 2. Negative 2 plus 2 is 0. The absolute value of 0 is 0. 0 minus 1 is negative 1. So my next point is negative 2, negative 1. Negative 2, negative 1. Let's put in negative 3. Absolute value of negative 3 plus 2. Well, negative 3 plus 2 is negative 1. The absolute value of negative 1 is positive 1. Absolute values make the number inside positive. Don't be confused there. Some people will make it the opposite of whatever the sign is on the inside. Don't do that. The number comes out of the absolute value bar is positive. So this negative 1 becomes a positive 1. And positive 1 subtract 1 is 0. So my next ordered pair is negative 3 comma 0. Negative 1, 2, 3 comma 0 right there. Put in negative 4. Absolute value of negative 4 plus 2. Well, negative 4 plus 2 is negative 2. The absolute value makes it positive. So positive 2. And positive 2 subtract 1 is positive 1. So my ordered pair is negative 4, positive 1. One more just to make sure. Negative 5 plus 2, that's negative 3. Absolute value of negative 3 is positive 3. 3 subtract 1 is 2. So let's graph negative 5 comma 2. 1, 2, 3, 4, 5, positive 2. Do you see the shape happening now? Yeah, I do too. So I'm going to go in here and do this. Now I can grab a ruler, put the arrowheads on the end because that means you're allowed to use any x value for your domain. Okay? You can keep graphing it until you get to positive 10 and negative 10, or your y values fly off your chart. But here you're not having to remember, oh, you know, my vertex is where this thing on the inside equals 0. You know, that's what I told you guys originally. What makes this thing here equal to 0? Well, that would be an x of negative 2. So an x of negative 2 right here gives you your vertex. If you look at this, this is interesting. You still see that symmetry across your vertex with an absolute value, meaning that here we have an axis of symmetry right here. If you've got a point 1 to the right, you should have 1 to the left. If you have a point that's 2 to the right of your axis of symmetry, you should have one that's 2 to the left. Do you see that? 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. Okay. Okay, so let's graph a square root function using this same strategy of just building just a big table. You can go from positive 10 all the way back to negative 10. I went ahead and set a few of these up. you can see I've used the function, the square root of x plus 1. That's your radicand. That's the expression that's under the radical sign. Once you take x plus 1 and get that sum and take the square root, then you take that answer and subtract 2. So I've set a few of these up. I went ahead and I took 0 plus 1, which is 1. The square root of 1 is 1. And 1 subtract 2 is negative 1. Now, you guys definitely need to practice with your TI-30s, the calculator you're allowed to use on the test. Make sure you know how this square root works. So I'd go get it right now and make sure you're coming up with the same numbers that I do. Okay, so my first ordered pair is 0, negative 1. So I'm going to graph that right there. And I'm going to then, I wanted to jump down to here. I put in 3. 3 plus 1 is 4. The square root of 4 is 2, and 2 subtract 2 is 0. I get a real pretty answer. I get 3, 0, and I can graph that. And that's right there. Okay, so I'm going to jump down to 8. I'm going to pop in 8. 8 plus 1 is 9. The square root of 9 is 3, and 3 minus 2 is 1. It gives us a real pretty answer. I have the ordered pair 8, 1, and I can graph that. Okay, let's work backwards now. I'm going to work backwards. I'm going to go right here. Negative 1 plus 1 is 0. The square root of 0 is 0. 0 subtract 2 is negative 2. So I get the ordered pair negative 1, negative 2, and I'm going to graph that. Now, I'm going to go ahead and do this one. I'm going to take negative 2 plus 1. That's negative 1. Take your calculator and take the square root of negative 1. What do you get? Your calculator should give you an error. If you do the next one, negative 3 plus 1, that's negative 2. What's the square root of negative 2? Your calculator once again should give you an error. Now there's no sense continuing in this direction because you cannot take the square root of a negative number. So I have found my starting point for the curve. It's right there. If you want to, you can go ahead and fill in the rest of these numbers. Now when you take the square root, say of 1 plus 1, that's 2. When you take the square root of 2, it's going to give you this really long decimal, and it never terminates and it never ends. Just go ahead and round it off to the tenth spot, and go ahead and graph that point. It's 1, negative 0.6. You can do that. Go ahead and do the next one. Pop in a 2 for x. I got negative 0.3, so I have the ordered pair 2, negative 0.3, and I can graph it right there. If you pop in a 4 for x, you'll be taking the square root of 5. So the square root of 5, then take that answer and subtract 2, you get 0.2, and you can graph that. And you can see that I continue to do that process. Your y values are all decimals, but they're graphable. You can do that. You can see how the curve is starting to fill in. And now the last thing you must do is connect all those dots with a line. And I have an arrowhead at the end, meaning I can continue to pick x values that head off to positive infinity. And we get this nice square root curve. So there's one last thing I want to show you. Take a look at that curve, and now take a look at this one. It's the same curve. I just didn't use those decimals. Here I just used my pretty y values. That's allowed. You can do that. You don't have to fill in all those little decimal dots in there. If you want to just use all the pretty numbers that fits, make sure that you've got at least 4 points that define your curve, and you're good. All right, I hope this video was helpful.